inverters. Welcome to the plus 10 video from this 2+10 playlist of Diesel Tent 2.0, converting a van a slightly different way. Okay, so if you're new to this channel, there's a link up here and a card at the end. You can click on that, it'll take you through to a video saying why we're doing it differently, what we're doing, a bit about the design concept and a bit about the nuances around this particular build. But if you're a regular subscriber, you know why you're here. So without further ado, let's get into the video. We're looking at the utility module, so heat, water and power, all the kit which is embedded under the kitchen unit. Apologies for people who click from the 2-minute update, there's a bit of a repeat here. But for those of you who saw the mock-up I'd done with all the foam models, the inverters and the MPPTs and all that, link there if you didn't. That was a really useful exercise, helped me to plan out what I wanted to do and basically a few changes that worked out well. Okay, now people who know my channel, I do things a little bit differently. So my channels are not about teaching you or anything like that, it's about what I'm doing. And coming from a prototyping engineering background, I tend to do things a bit creatively, shall we say, bodge. But I know what I can do and what I can get away with and what I can't. If you want to learn about electrics, you know, there's loads of great videos out there. They'll sort of show you all this electric porn, and they'll use words like set up, and you know, of course, if that electric porn is light blue in colour, you can get real hard on. But you know, I do things the way I do for a reason, and I'll take you through some of that. But no need to drop shade on the comment if you think it's wrong. I say this is not about teaching; it's about what I'm doing. Okay, so right, it's all under here. Let's have a look. Okay, so there is the utility module. It's basically in 4 quadrants. In the top left, you've got the power supplies. So you are going to have a 460 lithium battery in there. I'm waiting for the cost to come down a bit. Hopefully it will. I don't think it will. That's just a temporary battery I had. I just put it in to test all the systems. You can just about see behind that is the inverter, 3000 watt push-through inverter. Bottom left is the water system, hot water system. You've got a tank in there, and also you've got the pump for the general circulation. To the right of that, you've got the heating system. Now the diesel heater is not in there at the moment. I've had it in there, tested it and everything, but obviously it's going to be pushed through the floor of the van when I get it, so I haven't got it in there right at the moment. A little tank above that. Now I choose not to plug into the main tanks or diesel tanks. And above that you've got the electrical stuff. So 3 chargers, MPPT, AC to DC and DC to DC, plus obviously all the other stuff, sensors, isolators, fuses, bus bars, etc, etc. Now, I can hear the groans already. Think, oh no, another Victron fanboy. Well, actually I'm not a Victron fanboy. There's a very specific reason why I've used Victron in this situation. I should say, by the way, though, you know, it's probably a very good reason why Victron is the brand leader, but I haven't just gone for Victron because of that. Now, because this is an offline module and I'm cramming everything into the space under that kitchen unit, it's a little bit cozy in there, and yes, we've got plenty of vents, but there is a little bit cozy, and I am concerned about heat build-up, and Victron specify performance criteria for their kit against temperature elevations, and it's very robust. It tolerates high temperatures, and also I've come across a lot of people who have had similar setups, and I've even come across people who've had their kit laid flat on the side, so the cooling fins aren't working as efficient as they should do without any problems. So the data's there, this experience is there. That is why I've gone for Victron. I've no doubt that plenty of people have got very good kits, very good setups using Renogy or EcoWorth or all these other brands out there. So the MPPT, for example, works without any impairment up to 40 degrees, and then it will carry on working up to 60 degrees centigrade, which of course I'm not going to be going that high, with a very slight reduction in performance. But so that's fine. But to be absolutely sure, I've got some forced air circulation that I can kick in. There's a little sensor relay there that switches on if it gets above 30 degrees, so sort of 10 degrees in hand, forces those fans on, drawing air through the system to keep it cooler. So that's the reason I've gone for Victron. And of course, not all those 3 chargers are going to be operating simultaneously in any case. Okay, so I want to very briefly talk about water, because obviously this is a pre-made module in the sink unit that is pre-made out and we slotted into the van at a later date when we got the van. Okay, and there is a sink above that top right quadrant where I've got all the 12-volt DC electrical stuff in. I don't want to patronise you by saying electricity and water don't mix, but electricity and water don't mix. And there's going to be two sorts of engineers watching this video. There's going to be the TikTok and Instagram engineers who are going to be saying, bloody idiot's got a sink above his electrical stuff. And there's going to be the real engineers saying, Greg, you've got a water system in close proximity to an electrical system. What are the mitigants? What tell us about the cheese, to use the James Reason model? Okay, so what I don't want to do is just redesign, compromise the design to solve that issue, because you know where I come from, that would be nearly as bad engineering, so I'm going to unsafe system, not quite, but you don't do that. First of all, you look for the mitigants, and I think I've got enough layers of cheese to provide enough mitigants to make it a safe system. I'll just run through those layers now. Okay, so first of all, there's a physical barrier between the high and pressure sides of the water system. The tap is on the other side of the barrier, so we're just talking about a sink, in other words, a leaky sink. That is the threat we've got to deal with. The electrical stuff, good old Victron, is IP43 rated, so that would withstand like a rain shower, which is a lot more severe than sort of any leak coming from the sink. Okay, but of course, there's not just the Victron stuff in there. There's bus bars, there's like relay sensors, fuses, etc., etc. Now, the physical layout of that kit is such that there's quite a distance between the exposed positive elements and exposed negative elements. So you need to get a lot of water in there to cause an electrical short sort of damage by sort of effectively water shorting out the system. So that helps. But could that happen? Let's take, for example, the system was fired up and I'd left the tap running and the sink was leaking. Okay, the perfect storm, as we say in the engineering world. Could enough water accumulate there to do that shorting out of the electrical kit? Well, no, because underneath the outlet of the sink, in the bottom of that electrical module, there is in fact a 150mm diameter hole in the floor, so any water that does accumulate there potentially falls straight through into where the kerosene tank is. Okay, so you could never get enough water in there to cause any damage, any serious damage. Okay, but what else? Just say, for example, the leak was such that it didn't actually fall down, but it kind of tracked along the waste pipe, which comes off a spigot, then goes off through the chamber into another chamber. Say water managed to track along that, but then drip down, that was outside the perimeter of that safety hole onto some electrical stuff there. Well, that might happen, highly unlikely, but if it does, there's another layer of cheese, and that is outside of this 22mm diameter waste pipe, there's in fact a secondary pipe that sheathes that. So if that waste pipe did split for some reason, the secondary pipe would then carry on taking the water away out of the threat zone, the 12-volt DC threat zone. Okay, so I guess that's like the equivalent of doubly insulated in the electrical world where you don't have an earth. Okay, what else? Well, finally, around the actual waste outlet itself, the vulnerable area, there's like a cloth soak-up pad that will soak up the initial water that's caused by the leak. And in that pad, there's a sensor, a damp sensor, that sets off an alarm to say, oh, I'm getting wet. So I get a shriek going off saying, Greg, you've got a leak in your waste outlet. And then I can deal with it immediately. So, and I guess that you could say that's like the equivalent of a carbon monoxide alarm if you're in a gas, in your gas system, isn't it? So if the gas fire's not working right, carbon monoxide alarm goes off. So with all those layers of cheese, I'm quite happy that actually it's a safe enough system for me to operate without compromising the initial design. Some of you might disagree, and I would say if that's the case, don't do it. You've got to feel comfortable with what you do, but I'm comfortable with what I'm doing. But that's how I'm dealing with this issue of having the electrical and water systems in close proximity. Anyway, that's me done on the utility module. Thanks for watching. If you can do the like and subscribe nonsense, that'd be fantastic. And on with the project, and I'll catch you in the next one.